No one's saying not to go in the crater. I can? Is that okay? If I'd like to. Oh boy. Oh no! Oh! Whoa! If all goes according to plan, NASA's Project Artemis will have human beings back on the moon by 2025, and they're going to need a way to get around. That old Lunar Rover from the 60s, it's not going to cut it anymore. So we're here at GM's Milford Proving Ground to take a look at how they're developing a next-generation Lunar Rover in partnership with Lockheed Martin. And believe it or not, there's some Hummer technology in there too. We're going to take the thing for a drive, virtually anyway, on this RF Pro simulator and see just how that Ultium battery technology is being prepped for outer space. You've surely seen footage of the original Lunar Rover. There were three actually, one each for Apollos 15, 16, and 17. That last one 50 years ago this year. That vehicle too was designed with the help of General Motors, but it's safe to say that EV technology has come a long way since then. That first rover had 4 motors, 1 per wheel, with a whopping combined power of 1 horsepower. Yes, just 1, a quarter of a horse per wheel. That gave it a whopping top speed of 8 miles an hour, but a decent range of 57 miles from a roughly 9 kilowatt-hour battery pack. How does that compare to the new one? Well, GM isn't giving us formal specs on the new Lunar Mobility Vehicle, which is being designed in partnership with Lockheed Martin, because it's still in active and very early development. But given the new Hummer EV makes 1,000 horsepower from 3 motors and has 330 miles of range, I'm expecting the new LMV specs to be a little more impressive, even though it's not expected to have a top speed of greater than 12 miles an hour, a speed that I hope to break in my time behind the wheel. All right, here we go, taking our first steps on the moon, or first drive, I should say. So this is actual lunar data that's being used to generate this lunar surface I'm driving on, with about, I think 1 pixel every 5 meters was the resolution that they've got this scan of an area of the southern lunar pole, which is where Project Artemis hopes to set up. So obviously there's a lot more detail here than you'd get from 1 pixel every 5 meters, and so there's some procedurally generated data that's created a lot of these more detailed craters and rocks and things like that, and I've got full control to go anywhere that I want to. I've been told that I can go down some of these bigger craters if I want to, but we're going to take it a little easy right now because there's been a lot of warnings about motion sickness because of the lack of gravity. Now this is, again, an RF Pro simulator, the same kind of thing that you'd use in a NASCAR team, or like I did in that NSX drive. But obviously the big change they've had to do here was reduce gravity. We've got 1/6 gravity on the moon versus in the US. And so that's the big thing that we're testing out. What does that mean for a car? And speaking with engineers before, they said that, interestingly, you see a lot less traction. Now, you'd think that the highly abrasive lunar surface like you have on the moon would actually be good for grip, but because of the lack of weight of the vehicle, that actually reduces the effective grip of the vehicle, and so therefore we get a lot less grip and a lot less traction. So we're moving around here, we're doing pretty good. My stomach's feeling all right so far, so I'm going to pick up the speed a little bit. We've got, I think, a maximum speed of 20 kilometers an hour. I'm not going to be breaking any records today, but we'll see if I can maybe get a little air as we're going over some of these craters and lumps and things like that. Don't be fooled by the appearance of this interior, by the way. This is just a buck that I think is from a Chevy Blazer with what I think is a Corvette steering wheel here. So it's a bit of a mishmash of parts to pull this thing together. Really, though, the important thing is what's going on behind the scenes. The physics of this is really what's intended to give the GM engineers, hit a rock there, the GM engineers and the Lockheed Martin engineers some data that they can use to tune the suspension, the drivetrain, the differentials, and basically figure out how to get that 1,000 horsepower Hummer drivetrain to work on the moon. So far, we're doing pretty good. I haven't gotten stuck yet anyway. There's a big old crater over here. I'm gonna go aim for that. Let's see what we can do. Oh, a little drifting action here. Get some counter steer going. I think I'm floating. Uh-oh, am I high-sided? No, we're moving. Okay, we're good, we're good. This is a little different than the Lunar Lander game that I played in the arcades when I was a kid. A little bit more involved. The graphics are a little bit better too. All right, if you're listening out there, am I okay to go down in this crater? Am I going to get stuck? No one's saying not to go in the crater. I can? Is that okay? If I'd like to. Oh boy! Oh no! Oh! Whoa! Yes. Oh, I left tire marks on the moon. I've left my mark on the moon. I'm very proud of that. I crashed the simulator. Well, that was fun anyway. What a way to end my trip to the moon. I hope that the real NASA astronauts do a little better job driving than I did. The finished product should be a little harder for the real astronauts to crash. In fact, they may not spend much time driving it at all. The new LMV will be at least partially autonomous, scanning the terrain ahead and driving itself around with minimal instruction from engineers back on Earth. But it will have specially designed seats if a spacesuit-clad human being wants to get behind the wheel. Or a joystick. GM's engineers still aren't quite sure the best means of control. The overall layout of the thing is also still in flux, but a primary directive is the ability to haul both cargo and human beings, and unlike rovers from the past, this one must also be able to survive a lunar night. All those old rovers were left on the moon to die, their batteries and circuits destroyed from the 14-day, -200°F lunar nights. That was maybe not my longest ride in a simulator before, and certainly not my most successful, but it was a lot of fun. More importantly, though, it's through tools like this that GM and Lockheed Martin engineers are going to figure out how to make their Lunar Rover work, and more importantly, how to get some watts to freedom on the moon.